Hi, this is Steve with iFLOW and welcome to our video series. In this segment we're going to look at the advantage of decoupling, and we're going to look at it from the vantage point of min and maximum load matching so that we can create optimal Combi solutions. So the ability to decouple the three functions of HVAC equipment, and that was, if we recall, number one was to convert the source energy, whether that's natural gas, LP, or electricity, into heating and cooling. Then function number two was to transfer that heat and cool into the airstream. And then number three was to distribute that airstream through the house, right? So the distribution of it. So the ability to decouple those three functions gives the HVAC industry the flexibility to build better customized solutions, meeting the application by application need. So our partners, whether it's the HVAC designers, our wholesale partners, our contractor partners, builders, homeowners, now can select and install the best equipment that converts that source energy at the highest efficiency, for example, at the lowest minimum input, that meets the specific demands on an application by application basis. So, if I need 6,000 or 10,000 BTUs, I need to find a unit that can modulate down to a minimum input of that or less. And pairing that equipment with the most appropriate iFLOW model provides an optimal combination solution that can deliver superior performance and unparalleled comfort. So let's take a look. And we're going to focus on cycling reduction because that's where we're getting the best efficiency and where you'll get the best comfort. So we looked at, in one of our video segments, we looked at modulation. So better modulation is the key to better efficiency and better comfort. The greater the modulation range, the greater the comfort. iFLOW's air handler, blower, and pump, the modulation of those complements the heating and cooling source units, and combined together, when they combine them together, we create an awesome solution. So it's another reason you should consider an iFLOW combination. So let's take a look. So in this case, let's combine with a tankless water heater. So we've got the tankless water heater doing the heating and the domestic water. So we've got its normal domestic water application, and then we're just tying in with a unit and a pump to bring the heat into our hydronic coil on a call for heat. So the advantages, well, we've got great modulation. 10-to-1 is usually the minimum. It could be as high as 13-to-1. And we have great efficiency. Usually on the condensing tankless we are 94, 95% and up to 98, sometimes 99%. The only disadvantage is the higher we go on the minimum input on the tankless side to do the domestic water, usually the minimum input goes up as well. So for example, if I have a 200,000 BTU tankless at a 10-to-1, that means my minimum is 20,000 BTUs. But if I have 150,000 excuse me, if I have 150,000 BTU tankless and a 10-to-1, then my minimum input is 15,000. So again, I can match my maximum and minimum to make that work. Now, if I am concerned about that minimum input on the tankless and potential cycling, even though when we saw in a previous video the performance against the 95% two-stage AFUE, 95% AFUE two-stage furnace, we were up to 15% better at times. And that's with a 150,000 BTU tankless with a 10-to-1. So we can get much better great performance even with the existing tanks. But even if we wanted to reduce that more, here's a potential solution. So we have the tankless doing its normal domestic water application, and then we have the pump driving that into the heating side when there's a call for heat. But what if we added a mini tank? Right? We could decouple the call for space heating from the tankless. So let's say our minimum input on the tankless just for example purposes, 20,000 BTU is the minimum, let's say. But let's say the heating in our home, or the smallest zone that's calling for heat, let's say it has a demand of 8,000 BTUs. Okay, so if we have 8,000 BTU demand on the heating side, the tankless is going to cycle a little bit on that because its minimum input is 20,000 BTUs. Okay, so can we do something about that? So let's try it. Let's put in a tank. We can put in a tank and we can size it to the heat load that we're trying to overcome. So we know we've got an 8,000 BTU heat load on the heating side, was our hypothetical. So if we put in a 10-gallon tank, that'll hold 8,000 BTUs. That might be a little tight, so why don't we go with a 20-gallon tank. We're going to be able to store almost 17,000 BTUs. So when we pull out 8,000 BTUs, no problem at all, we'll still have 8,000 left, so it's not good. It's going to minimize the cycling on the tank as well. But with this tank, so we include the cost of the tank, and we have a little pump. If this is an electric water heater, for example, the electric water heater, its element is running at 120 volts. It can actually wire, instead of turning on the element, we can have it such that it turns on the pump. So we have our own aquastat built in. We have our own 120 volts already built in, so we don't need anything else there. We wire the control to the pump instead of the element. The pump then comes on and it pushes the water into the tank, and it does that circuit to recharge the tank. So in that case, only when the unit goes below, let's say that 15,000 BTU mark, will it bring on the tankless. So we'll get some decent efficiency that way, and we'll reduce the cycling. And if that tank has a UEF of 0.92 or an energy factor of probably 0.93 or 0.94, it could be a great solution. So again, I'm not advocating, I'm just saying if we're looking at reducing the cycling, this is one option if we are concerned that the cycling on the tankless would be too much, even with the minimum input being relatively low. We can do that, so we can do it with the mini tank, or now we can switch over and put in an inverter heat pump. So if we were looking at an inverter style AC unit, the cost difference between the inverter AC and the inverter heat pump is not that significant, and now if we went to heat pump, we could actually do some heating. So we could let the heat pump do the heating in the shoulder seasons when those low BTUs would be required, and maybe the tankless would be cycling a little bit. We can let the heat pump do it at a fairly high COP. If we have COPs of 6 or 5 or 4, that would be great performance on the heat pump side. And then once we get into the depths of winter, let's say the December, January, February months, when we know the heating demand will be higher, then we can come in and use the tankless. With the iFLOW, we have that capability built in. With our outdoor sensor, we run the sensor outside. If we then plot the COPs of the heat pump and say, okay, let's say when it's above freezing. So let's say if it's 35 degrees and above, or let's say 0 Celsius or close to that above, then we will run the heat pump, and then below that we'll switch to the gas side. We at Navien, we have an outdoor sensor that's looking at the outdoor temperature, and then we can program those numbers in. We take the thermostat call comes into the iFLOW, and then we are connected to the pump which drives the Navien, and that turns on the heat pump. So we can look at the outdoor sensor and then decide which heating device do we bring on. Do we bring on the heat pump, or do we bring on the tankless? We look to the temperature that's been set by the contractor, by the homeowner, and we use that as our metric. So it's very simple, all built in. We can control that switch over. That's part of what we do at iFLOW. Or what about this? So now we said, okay, well, We're not going to, tankless minimum input might be too high, although we don't think so, and that's not what the testing has shown. But let's say for theoretically it is. And then the heat pump, we don't want to spend money on the heat pump. Maybe there's no air conditioning in this home. Okay, well, we can look at a boiler. So if you look at this boiler option, we have this 60,000 BTU boiler that has an 8 to 1 turn down ratio, so we're down to 7,000 as the minimum input with an AFUE of 94. We have another option here. This is an 8,000 BTU minimum with an AFUE of 95%. So we could put either of those options in. We supply the heat over to the unit and deliver that out, deliver that low BTU at the high efficiency without cycling at all. So again, when we're looking at minimizing the cycling, maximum efficiency, maximum comfort, these are possible solutions. So if we look at a home, let's say we're looking at this home where we've got a heat load of total heat load of 23,000 BTUs, and it's zoned. We have the top zone requiring 7,500, ground floor requires 7,700, basement requires 8,000 BTUs. If we look at the CFM rate, those are very low. But if we install this boiler that has an AFUE of 94, so if we were looking at a 60,000 BTU furnace, and again for this size of house, let's say rule of thumb, you would probably go with a 60,000 BTU furnace. Let's switch that out and run with a 60,000 BTU combi with this boiler, and then we can run some zoning. So now we can run with this boiler running at 7,000 BTUs on the minimum, so it meets the minimum for each zone, so it'll run at good efficiency and meet the zone input. We can run at these CFM rates without problem. We can easily zone, so we're designing, if we need 7,000 BTUs on the top floor, easily. We call it on, we start the heating at 142 CFM, bring the boiler on, it delivers at 7,000 BTUs at 94%. It's a wonderful system, perfect, no problem at all. What would a furnace be doing in that situation? If we put that 60,000 BTU furnace, even that fully modulating, fully condensing unit that has a minimum of 40% on its load, 24,000 BTUs, it would be cycling terribly on this whole home. Even at maximum load, it probably would still be cycling. So this is a much better solution than that 95 or 98% AFUE furnace, without question. Let's say they did want air conditioning in this home. So now we have the boiler delivering perfect heat throughout the home with the distribution. We've got great comfort on the heating side, delivering just the amount of heat in just the right area that we need. And now we're going to run the heat pump. Well, we can run the heat pump at very high COPs of 5 or 6 in the shoulder seasons and deliver through, and then go to the boiler when it's in the middle of winter, and again have great performance on that system. So again, these are just different options, different combinations that we can put together to minimize that cycling. One of the advantages of the boiler side is that we can do radiant heating as well. I've been asked by many builders, hey, now you can do the forced air, can you do some radiant heating off that? We want to put some tile in the kitchen. We'd like to have that. We'd like to have some radiant in the kitchen, maybe in the entrance, maybe a towel warmer in the bathroom. We can do that. So we can take that boiler that's going to run the radiant at great efficiency. It's going to run the air side at great efficiency, and then we have the heat pump doing the AC and potentially the shoulder season heating. So again, all great options, different combinations, but we can do all of that. One of the downsides of, let's say, this solution is that there's no domestic water. Okay, how am I going to run my domestic? I can easily put an indirect tank off this as another loop. It could be a little bit more expensive, but it's an option for sure. Or we can go with a combi boiler. So now we're looking at a combi boiler In this case, we have 110,000 BTU combi boiler with a minimum input of 11,000 BTUs. This will do the equivalent heating of a 50-gallon gas-fired water heater. So a lot of capacity here. We can tie it in. We've got still a good minimum input, and then we can leverage off the heat pump as well to help us in the shoulder season. So again, another option. But now we have a boiler, the great turn down with the domestic water and with the heat pump to help us in the shoulder seasons. We can do all electric solutions, so we're not tied to one heat source or another. We're agnostic. We can do any of them. This situation, we're dealing with an all electric solution. So let's say we have a heat pump to an AC unit, an inverter heat pump or AC to do the heating, or do the cooling, and maybe some of the heating. We can run the electric water heater or the heat pump water heater in this application. The heat pump water heater can do our heating, our hydronic heating, and it can also supply the domestic water. So if we were going to do this, we would perhaps oversize the tank a little bit because it's doing both. So let's say we didn't have the heat pump outside, and we were just running the heat pump water heater to do both the heating, the air heating, and the domestic. We didn't need any cooling, for example. We could easily oversize this tank a little bit because we're doing both the domestic water and the space heating. Oversize a little bit, deliver through on the heating side. We'd get great performance at great COPs. You'd have a COP of likely 4 or 3, depending on the season. So great efficiency that way. Great performance here. Oversized to be able to do both. Worst case scenario, let's say we're in the middle of winter and we're not getting the heat pump performance that we had hoped. What's it going to do? It's going to default to backup. So it's going to go into backup mode. Well, the backup mode will have, it's going to go to the elements. The elements have great efficiency at, a UEF or an EF of 0.95, 94, 96, somewhere in that range. We're going to still get great performance out of the tank, even if it's in backup mode with using the elements. So this could be a great solution if you're in a townhouse or in a condo application where you have you don't want any exhaust vent, you don't have any gas in the building. Could easily be a great solution. And this could be a solution where we don't have any gas at all. This is another all electric, no water solution. So we actually could, we have a mini version where we don't have any hydronic coil. So you still have the distribution capability, right? We have our blower, we have our zoning, we have our Wi-Fi, we have our full modulation, so you're getting all of that. But then you're getting a COP of 6 on the heating side using the heat pump. So this could be in some of the warmer southern U.S. climates where a heat pump would deliver all of the cooling and all of the heating. Your heating seasons are going to be fairly short. Heat pump could easily pull that amount of heat and deliver it to the space. Could be a great solution. So again, all electric, some gas, some mixed, depending on what your preference and what your situation is. But all to say, the iFLOW being the center of the distribution is a great partner because we can modulate fully from 0 to 100%, and we have the zoning to be able to make that distribution even better, and we have the Wi-Fi app to be able to control it. It's a great pairing. It's a great pairing for a great solution. On the multi-res side, we can operate in those situations as well. If we have a boiler loop in the building and we want to pull off the boiler loop into the air handler, we can easily do that. If we have a chiller in the loop or a chiller loop in the building and we want to pull in and do the AC off the chiller loop, we can do that as well. We can do that in one single coil if you have a reversing valve in the mechanical room of the building. Or we can do it with 2 coils. We can do one heating coil and one chiller coil. So either option we have available, but all to say, we can do these solutions without problem as well. And then in these solutions, the app is such, our app is such that all of the units that you have installed can be listed and scrolled through on your phone or on your computer. So for a property management company that wants to manage all of the units that are installed in the building, we can easily do that through our system, and it can all be on one interface. So all to say, you bring the heat with whomever you like, whichever partner you want to dance with, and we'll create the hot air. So again, we can do it with any tankless unit, any boiler or combi boiler, with any tank type water heater, any heat pump water heater, or even any heat pump. So any of these options are great partners for the iFLOW, and will give you premium efficiency on your system, and premium comfort as well. So as such, iFLOW is an energy transfer and comfort distribution company. Really, we're specializing in the transfer and delivery of that heating and cooling to any part of your home in any amount with the highest efficiency and the greatest of comfort. So our modulation that we have in our unit, the modulation of the blower, the modulation of the pump, the modulation of the distribution system, that modulation complements the capabilities of our Combi-system partners. So when we combine with a great boiler like we saw, or a great tankless in the Navien or the Rinnai, for example, or with a heat pump and get great COPs, when we partner with any of those, we create a high performance system that's cost effective and meets the challenges and the expectations of the homeowner. We solve those problems, and that is key. We solve the problems of the industry and deliver what the homeowners are expecting. So we thank you for your time. We hope the information has been helpful. If you have any comments or feedback, iflowhvac.com. You can reach me on my email address, steve.bagshaw@iflow.com, iflowhvac.com, or toll free or on my cell. So again, thank you for your time. We appreciate your interest in iFLOW, and we're looking forward to your feedback. Thank you.